Hello from Nonlinear Labs in Berlin. Our C15 is a synthesizer that can behave like an acoustic instrument by using the oscillator section as exciter and the comp filter as resonator. With the Spring 2023 update, we introduced new signal routing possibilities, including the possibility to connect the two parts of a split sound via the feedback mixer. This allows new ways of distributing the excitation and the resonances in two parts that can be played independently. In this tutorial, we will show how the C15 in this configuration models a resonator where the resonant frequencies can be determined independently by pressing specific keys. Resonance is one of the most important phenomena in acoustic sound creation. From stringed and percussive instruments to wind and bowed instruments, the interplay between an exciter and a resonator is a fundamental principle of generating and shaping tones. In a piano, a hammer strikes a string. Similarly, a guitar string is hit by a plectrum. In wind instruments, a mouthpiece is used to create turbulences, where standing waves selectively amplify resonant frequencies. If multiple resonators like strings are present, sympathetic vibration can create a kind of internal reverb. You can demonstrate this yourself if you have a piano at home. Press slowly some keys in the lower key range to lift the dampers from their strings and play some notes in the upper key range. If the frequencies of the played notes are harmonics of the undamped strings, these strings will also vibrate. This principle of sympathetic resonance also applies to instruments like the sitar, where plucking a single string doesn't just produce a note. The vibration excites sympathetic strings, reinforcing and enriching the sound. The result is an intricate blend of overtones, sustain, and evolving harmonics. The C15's voice group architecture allows to create an exciter-resonator relationship in split sound configurations. This is the architecture of a single sound. A and B are the oscillators and shapers. COM and SVF are the comp filter and the state variable filter. These components are connected to the output mixer. After that, the signal is routed to the effects group and to the output. The signals from the comp filter, SVF filter, and effects can be also routed back to the inputs through the feedback mixer. The dual modes of the C15's sound engine provide layer and split configurations, where the total amount of voices are divided into two groups, also called parts. In split mode, the two parts are assigned to two separate keyboard ranges. Part 1 can be played between the lowest key and a split point, and Part 2 between the split point and the highest key. Since 2023, it's possible to couple the two parts via the feedback mixer. Now we can assign different roles to each of the two parts. As a first example, Part 2 as exciter. It generates short percussive impulses or tone bursts, similar to a pluck, by using oscillators and fast envelopes. Part 1 as resonator. It creates the actual tone via the oscillations of the comp filter that occur when it receives an exciter signal while it is set to a high internal feedback. We pick up the signal from the opposite part, let's say from Part 2 to Part 1, through the feedback mixer of Part 1. The feedback mixer allows the signal to reach the comp filter in Part 1. Every key that we press in Part 1 will open the signal path to the comp filter for its voice. Holding down keys with the left hand and triggering exciter signals with the right hand can be compared to playing a guitar where the left hand sets the pitch for the resonators, the strings, and the right hand plucks them. Let's now manually two split resonator presets directly on the C15. You will find them in the split tutorial bank. The C15 has two different user interfaces. The hardware user interface, with hands-on controls for quick access to all parameters, presets, and settings, and the graphical user interface, which is available on external devices via Wi-Fi We will do all the parameter changes on the hardware user interface, using the graphical user interface simply to help visualize the adjustments in the parameters group in real time. We will also mirror the OLED display for this purpose. First of all, let's initialize split sound mode, holding down the default button in the sound or preset screen and pressing down soft button 3 as split. On the sound screen you can press soft button 1 to select part 1 or part 2. The two parts are now completely empty and silent. Let's start to create an exciter without tonal component. We choose part 2 to play the exciter with the right hand. Let's start with oscillator A. It sounds like a pure sine wave, and to add more bite, we can create a wider spectrum through self-modulation. The tonal component is still present. By playing different keys, we hear a different pitch. To eliminate it, let's turn the pitch key tracking down to 0. Now let's mimic the percussive sound of the plug by using a fast envelope decay. Part 1 will be the Resonator. To pick up the signal from part 2, here we go to the effects channel of the feedback mixer and set the crossfader to 100%. Then we turn effects level in the feedback mixer to 50% to get the signal to the feedback bus. We turn as well reverb mix and drive to 0, because we want to pick up the clean exciter signal without any effect or distortion. The level can be set to a neutral 0 dB. Finally, we open FB mix of shaper A to 100% to route the feedback signal to the comp filter of part 1. Now let's play with the comp filter. To open the signal path, we need to press a key of part 1. The comp filter mainly consists of a delay and a feedback loop, mimicking how waves propagate on a string and are reflected at its ends. Longer decay times increase the amount of feedback and therefore the resonance. We let the noise burst from part 2 reach the comp filters in part 1. This will only affect the voices of part 1 that we enable by playing the related keys. It's interesting to note that whereas the exciter is atonal, the comp filter in the resonator part is tuned according to the keys pressed. A low pass lets the higher frequencies decay faster. We can increase the dynamic response of our exciter by adding an envelope amount to the self-modulation. In this way, the timbre is also affected by velocity. Some flanger and reverb could further improve the final result. By pressing the keys in part 1, you tune the frequencies of comp filters of the voices that you play, just like picking chords on a guitar. You can also mimic the phenomena of sympathetic resonances by adding a tonal component to the exciter. For this, we tune the pitch key tracking of the oscillator in part 2 back to 100%. By using a longer decay time, the tonal component becomes more evident. As a result, you can hear different pitch for each exciter's key you press. We can make the sympathetic effect even more evident by reducing the self-modulation. By doing so, we reduce the oscillator's high-frequency noise and increase its tonal content. When you hit a key in part 2, you produce a tone that has harmonics which can excitate the ones of the resonator in part 1. We speak of narrowband excitation, because if the frequencies are not close enough, part 1 will not react as much. On the other hand, if the frequencies match, you will get a similar behavior like with a sitar, where additional strings, which are not plucked, resonate sympathetically. Again, we can add some effects to make the sounds more interesting. We have seen how in a C15 split sound you control the tuning of exciter and resonator independently, which is a new and interesting way of interacting with the instrument. The result is an intricate blend of harmonics that can reinforce and enrich the sound or create interesting dissonances, according to what set of keys you press.